Hello, today we will be exploring polynomial functions and their characteristics for new types of functions for us in grade 12. It's quite a lengthy note and a lot of writing. You guys have been looking at the definition of a polynomial function for years, so let's just skip over that part and get right to it. We already know two polynomial parent functions. I mean, you guys have worked with more before, but we're very comfortable, hopefully, with linear functions. So mx plus b and quadratic functions, which is ax squared plus bx plus c. And we're focusing on these, on our knowledge of these, because linear has an exponent of 1 with its variable x, quadratic is exponent 2. And today we're going to look at cubic, quartic, and quintic. So what those mean is cubic is x to the power 3 as the degree, quartic is x to the power 4, quintic is x to the power 5. Okay, and what they look like on a graph, so the parent functions are all going to go between 0, 0, 1, 1, and in this case for a cubic, negative 1, negative 1. And it kind of looks like linear, where it goes straight through, but has a bit of a curve. Okay, so it's going to go up like this. It's going to curve like that. Okay, so anything to the power 3 at an x-intercept will have a slight curve like that, rather than going straight through like linear. Okay, quartic resembles quadratic in a parabola, but as a parabola goes right down to the x-intercept and right back up, quartic takes a little bit of it has a little bit of a flatness to the x-intercept. Okay, it doesn't just go right to it and right back up. It kind of flattens out a little bit. I'm just going to draw that left side a little clearer. Okay, so it comes and kind of goes flat for a little bit. Okay, and then we have quintic. Again, going through 0. This one kind of looks like cubic, but again, a more defined flat line as it reaches the x-intercept. Okay, so it's almost like this, a more defined flat line. Okay, so what we need to get from this is when your degree is an odd number, the bigger the odd number, the flatter the line, and it goes through, like it goes from negative to positive. If your degree is even, it won't go through, it'll turn back around, and the bigger the number, the flatter the line. Okay, looking at this chart here, constant difference, domain, range, and possible graph for each of these. So linear has a constant difference. The slope is the same no matter what, so yes. None of the other ones have a constant difference. Okay, the domain for all of them and the parent function is going to be XER, right? All negative and all positive, so all real numbers, could be used to find a solution. Range is where there's a limitation. In linear, straight through, YER. Goes up and down forever. Quadratic, we know, has a minimum or maximum. So it has a turning point, meaning it has a restriction. In the parent function, it's 0. Okay, cubic, an odd degree, goes up and down forever. Quartic, an even degree, will have a restriction at 0. And odd degree quintic is just YER. Okay, and then the possible graphs, we've already kind of looked at these, so let's just do this quickly. So linear goes straight through, quadratic touches and goes back up, cubic, a little bit of a curve, quartic, a more defined, and then quintic, a more defined, goes straight through. Or go through, not straight through. Okay, characteristics of polynomial functions use Desmos. We're not going to do that. We're just going to go through this chart. You can look on Desmos if you want. All right, so is the degree even or odd? So in this first one, again, the degree is the largest exponent number. This is quadratic. The degree is 2, so it's even. Degree of 4, so even. Degree of 3 is odd. Degree of 6 is even. Degree of 5 is odd. Degree of 2 is even. And degree of 7 is odd. Okay, the leading coefficient. So the number, in front of the degree variable, so that the coefficient with the variable that has the largest exponent. So x squared is a leading coefficient of 1, x to the power 4, leading coefficient of 1, 1x3, negative 2, x to the power 6, negative 1, x to the power 5, 1x squared, and negative 5, x to the power 7. End behaviors. So this, if we go back to our graphs, these are how do the arrows look. The further left you go, is it going to positive infinity or negative infinity? The further right you go, same it. Okay, so with even degrees, that means that just like quadratic, it goes down, touches a spot, and then goes back up, so the arrows are pointing the same way. As x approaches negative infinity, so as it goes to the left, y approaches positive infinity. And same to the right. As x approaches positive infinity, y also approaches positive infinity. Okay, here's another new thing, number of turning points. So to figure this out, you take the degree number and subtract 1. So quadratic has 1 possible turning point. For the number of possible zeros, it says number of zeros here, but it's possible, it's the degree number. Right? Quadratic has a possibility of 2 x-intercepts because it's squared. Okay, next one, an even degree. So that means the arrows are facing the same way again. It's a degree of 4, so there are 3 possible turning points and 4 possible zeros. Okay, odd degree, so this time the arrows are facing the opposite way. So as it goes left to negative infinity, the y also goes down to negative infinity. And as it goes right to positive infinity, the y values go up to positive infinity. It's degree of 3, so 2 possible turning points, 3 possible zeros. Even degree 6, so arrows facing the same way. Now this was a negative 2 coefficient, so that means the arrows are both facing down. It's a 6, so number of turning points. There are 5 possible turning points and 6 possible x-intercepts. Okay, again a negative, so it's flipped, but this time it's odd. So normally, as you go left to negative infinity, with a positive leading coefficient, you'll go down to negative infinity. This time it's the opposite. So x as negative infinity creates y as positive infinity, and x as positive infinity creates y's to negative infinity. It's degree 5, so we have 4 turning points, 5 x-intercepts. Okay, this is quadratic again, it's positive, so they're both going to be positive infinity. 1 turning point, 2 x-intercepts. And the last one, odd and negative. So positive infinity, negative infinity, with 6 possible turning points, 7 possible x-intercepts. Okay, so the information we need to know, the n behaviors, if the leading coefficient is positive in odd degree polynomials, so when x is approaching negative infinity, y is approaching negative infinity. Yep. And when x is approaching positive infinity, y is approaching positive infinity. Okay, and that's just right from the chart that we did before. Okay, well, what if the leading coefficient is negative? Okay, if leading coefficient is negative on odd degree polynomials, as x approaches negative infinity, y will approach positive infinity, and as x approaches positive, y will approach negative. Okay, for even degree polynomials, the n behaviors, switch to purple here. So if leading coefficient is positive, when x approaches negative infinity, y approaches positive infinity. Remember, for even degree and it's positive, no matter what way the x's are going, the y's will be approaching positive infinity. And if the leading coefficient is negative, both y's will go to negative infinity. Okay, turning points. So with odd degree polynomials, the number of possible turning points is 1 less than the degree number. Okay, and this isn't just the case for odd degree polynomials. It is the same for even degree polynomials. Okay, number of zeros, and it's going to be the same again, but the number of possible zeros is the same as the degree number. Okay, domain for either odd or even degrees will just be XER unless otherwise stated. The range. The range has restrictions. If the leading coefficient is positive, it's YER, where y's are greater than 0. If the leading coefficient is negative, it's y is equivalent to all real numbers, but y must be less than 0. Okay, with even degree polynomials, since they go you know what, this is my mistake. Just ignore that part. With odd degree polynomials, they go up and down forever, so it's YER. Okay, for even degree polynomials, you can just write an arrow over if you already wrote. Okay, sorry about that. And the symmetry, the functions in odd degrees are either odd or neither. And for even degree polynomials, the functions are either even